Good afternoon, all. How's it, guys, girls? I see we've got a couple of people online already. For those that have just joined us, my name is Tyrell. We haven't started just yet. We're going to give it a few more minutes. To make sure that everybody can see my slide. It should be displayed. I have checked with some of the other participants already, and everyone should also be able to hear my audio. Like I said, I'll give it a few more minutes before we start. I see it's now going on 2:30. I think let's wait for another 2 or 3 minutes and then we'll get cracking. Okay, well, I think I'm going to get started. So firstly, I would like to say thank you and welcome. My name is Tyrell. I'm the technical manager at Modena OneSolve. I've been with the Modena Group for going on 13 years. And my primary focus within the group has really been around Plant3D, Navisworks, and the data management spaces, mainly behind the firewall. That is really where I've spent most of my time. With these introductions, I know they normally say that we should say something quirky or two, and I thought of a way I could kill two birds with one stone here. And I'm pretty sure that anyone on call who has children could maybe relate. So I am the proud father of a 3-year-old. And one of my greatest achievements, and it's actually been an achievement that I've been going on for quite some time now, is being able to navigate in the dark, in the middle of the night, from my bedroom to my bathroom without standing on a Lego block. Now, I don't know if the other parents have experienced it. I'm pretty sure they have. There is nothing quite, or nothing as entertaining for a spectator to witness. You know, if you've stood in the Lego block in the middle of winter, in the middle of the night, it is definitely quite something to see. But anyway, so that is my achievement. I'm now able to bypass those Lego blocks. I've got pretty good at it. Yeah, moving on. So really today's webinar session is around process and structure. And the session really just going to cover some of the key features that were introduced this year with Plant3D 2021. For those of you that were with us yesterday, you will recognize the first few slides. They are related to Plant3D. We'll have a look at some of those new features. And then we're going to have a look at the collaborative workflow between two disciplines, like I've mentioned, process and structure, and how we can better leverage and communicate design data between Autodesk Plant3D as well as Advanced Steel. So just to go over the agenda real quick, we'll have a look at those new features. They really are around installation and collaboration on the Plant3D side. And once we've gone through those new features, we'll move into the process structural workflow. Okay, so starting with those new features regarding installation, there's really two areas of installation that they've improved. One is on ortho drawings, the other is on the actual model itself, in the actual 3D model. In terms of ortho drawing improvements, installation is now displayed with the pipe objects in orthographic drawings. And over here, you can choose to either hide the installation lines, hide the pipelines behind the installation, or show the pipelines behind the installations in orthographic drawings. On that, with existing ortho drawings, you can also use the installation tool to place installation symbols together with the installation type and thickness. You can see it in the first image on that slide. Moving across to the actual improvements around the model. In terms of the 3D model and installation, there is now transparent display of installation. So there's no longer just this, exaggerated view of your pipe. It's not like you're looking at an odd pipe size when you turn on installation display. In 2021, that's now transparent, so we have better visual feedback as to whether installation is being applied or not. For users who are not utilizing Plant3D, so standard AutoCAD users, let's say, if you export your Plant3D models out to DWG, the transparent installation will export as a 3D solid. it gets placed on a layer, and that can be toggled on or off using standard layer control in normal AutoCAD as well. So that option is there, at least for non-plant users, if they are viewing data that's been exported from Plant 3D. Just before we go any further on Plant 3D, there's a couple polls that we'd like to run today. So I'm going to just load up one of those polls right now very quick. You should see something popping up on your screen. And it's really just a quick multiple choice. If you can, give it a vote, yes, no, or would like to. We just want to find out how many of the guys currently online are utilizing Plant 3D. So I'll give you guys maybe 20 seconds or so if you guys can go and vote on that for me. And then we'll move through to the other new features inside Plant 3D, which is really around the collaboration space, which is also probably the most exciting introduction this year. Fantastic. Okay. All right, guys, I'm going to end this polling session. Thanks very much for that. I see that we have quite a good mix between those that would like to, those that are, and those that haven't yet used Plant 3D. That's fantastic. Let me end this polling session. Let's move on to the next portion here, which is really around collaboration. Let me move that portion out of my view. Okay, so the next portion really that's been improved was collaboration. So the collaboration service is now based on the latest BIM 360 technology, making it faster and more stable. Now, aside from replacing BIM 360 Team with the document management module in BIM 360, the collaboration workflow remains the same. BIM 360 Design is a cloud-based solution that integrates with the AutoCAD Plant 3D 2021 toolset to provide an enhanced cloud collaboration experience. So in this release, on top of that, you can now directly share a cloud-based file between AutoCAD Plant 3D and the document management module on the BIM 360 platform. Leveraging the document management module, permission management is now available in that collaboration workflow. And with this feature, project teams and the extended stakeholders can securely collaborate and share files and data across locations and disciplines. So what I've got next up for you is really just a short video which highlights some of the collaboration around Plant 3D and BIM 360 Design. I'm going to start that video for you real quick.
Autodesk understands the struggles faced by plant designers and engineers when collaborating across teams and locations. That's why Autodesk created BIM 360 Design, the cloud-based collaboration solution for AEC professionals. BIM 360 Design, now with collaboration for AutoCAD Plant 3D, delivers an enhanced collaboration experience for plant designers and engineers. This allows for secure sharing of Plant 3D files and data between plant designers, engineers, and stakeholders. Plant 3D users can also share P&IDs with Revit users, providing them with a view of the overall plant design. Let's look at an example of how BIM 360 Design improves workflow collaboration within Plant 3D. First, the project administrator sets up the collaboration space in BIM 360 Design. The administrator then adds the project collaborators and defines the appropriate permissions before sharing the Plant 3D project to the collaboration space. The P&ID drafter will then create the P&IDs for the project. The piping designer will then create the 3D piping models using the P&ID as guidance. Drafters will then generate the necessary ortho and ISO drawings from the 3D model, including documentation such as bills of materials. All Plant 3D project DWGs from P&ID to 3D piping model to ortho or ISO are all automatically visible in BIM 360 Design when working in a collaboration project. The project manager can check the progress of the project at any stage and assign tasks as part of the review process. With Autodesk collaboration for Plant 3D and BIM 360 Design, users can manage permissions, share data easily and securely, and get more out of the software they already love.
Fantastic. Okay, so that was just a short video clip on that integration between BIM Design and Plant 3D. Like I say, I think it's fantastic, and it's, for me, one of the greatest things to come out of the plant stable in a while. So moving on into the process structural workflow. So for the purpose of this workflow explanation, we'll be creating the conceptual spatial representation structure inside of Plant 3D. And then using Advanced Steel, we'll import the Plant 3D structure, configure and set up any steel profile mapping if there are steel members that are not currently residing in the Advanced Steel library. The Advanced Steel drawing will then be copied back to the Plant 3D project and referenced where required using standard X-ray functionality or features. So just on this as well, I want to just mention that unfortunately Joanne couldn't join us today. She's currently busy with some training that she needs to deliver. So any questions around Advanced Steel at the end of this session, we will take note of and we'll get those responses back to the members or to the participants who have got questions around Advanced Steel. So if you have got any questions around Advanced Steel by the end, please, if you can, utilize the chat feature within this meeting. We can then get those questions answered for you. Okay, so we're going to start off really on the plant side and exporting the information from Plant 3D. So when exporting from Plant 3D to Advanced Steel, all the structural member information from Plant 3D will translate to Advanced Steel, keeping the model intelligent and reducing the rework often required. The export format that is utilized from Plant when going out to Advanced Steel is known as a SMLX. We often just refer to it as a Advanced Steel XML file. From there, that file would then need to be imported back to Advanced Steel. Now, importing the Advanced Steel XML is a fairly straightforward process. During the import, Advanced Steel will convert the steel members based on the Advanced Steel library. Now, if no mapping exists, and just to kind of highlight on the mapping here, when I'm bringing something in from Plant 3D, so let's say I've got a IPE 200 that was exported inside Advanced Steel, when I import that, if an IP 200 doesn't exist, then obviously it needs to either be created, the actual profile, or perhaps maybe just mapped to a similar profile that might be suitable in that condition. Now, when we create that mapping, it's a one-off. We won't have to redo it, and that mapping information is stored. Okay, just on that as well, when the information is imported into Advanced Steel, you will find that a lot of the plant information translates, and that way we can leverage what's already been done on that conceptual model file. To then leverage the Advanced Steel file in Plant 3D, this is now when we're going back. So maybe just before we touch on Plant again, on Advanced Steel, once that data has come into Advanced Steel, by the way, that file behaves just like an Advanced Steel drawing, and the structural team can edit and manipulate that data as they would an ordinary Advanced Steel DWG file. Going back towards Plant 3D, for Plant 3D to now leverage that Advanced Steel file, and typically what we would do over there is we would copy the drawing, and this now being the Advanced Steel drawing, to our Plant project, and that's where we then use that X-ray functionality to then reference that structural design within the Plant project. The Advanced Steel users going forward will then access the structural file within our Plant project location to continue any structural work. Obviously, any changes that are made to the structural file will reflect throughout the Plant project wherever that structural file is being referenced. Something to note here, which is very important, it's actually imperative. If you are going to be leveraging your Advanced Steel information inside Plant 3D, it is imperative that you download and install the Advanced Steel Object Enabler. This will enable the display of those Advanced Steel graphics, as well as the metadata from Advanced Steel that actually makes that visible within Plant 3D as well. So we've actually got two little video snippets that we've created. It was done by myself and Joe. The first one really is one that Joanne created, just going through this process, how we would bring that information into Advanced Steel and how we would take it out of Advanced Steel and then leverage that information once again inside of Plant 3D. Just before we start with these small little video clips that I'd like to show you, I have got a second poll that I would like to launch very quick. If you guys don't mind, you should see something popping up on your screen. If you could have a quick look at that and a quick vote on what's coming up. Sorry, it looks like my poll didn't want to come up with the video being displayed in the background. You switch through to the next one here. So you should all actually see something popping up regarding collaboration or multidisciplinary environments. If you could have a quick look at that and a quick vote on that. Are you currently working in a collaborative or multidisciplinary environment? Okay. All right, guys, so I see that the majority of you are working in a multidisciplinary environment or in a collaborative environment. That's fantastic. Let's have a look at that first video clip on how we bring in that Plant 3D information into Advanced Steel. Move that down. This video should start playing. So like I've mentioned, this video Joanne actually recorded for us. It illustrates the process that one would follow in order to leverage that spatial or conceptual structure from Plant in Advanced Steel. So the Advanced Steel XML would be imported. In this particular case, when Joanne imported that XML that we gave her from Plant 3D, there was no mapping that was required on those steel profiles. There you can see how that structure has come through from Plant 3D. You will find as well that the information does translate from Plant to Advanced Steel. You can see how the steel profiles are there. You even have the justification and offset options coming through as well. From here, you know, the structural team would continue with detailing or modification on the model. In this case, Joanne just placed a couple of base plates down for us just so we could see an update on the plant side. So let her populate those through quick, so you should see those go through. And, you know, from here, this file would just be saved ordinarily. And we would then copy that file into our plant project, which would really be the next step. So I'll wait for this to finish playing through. I see that it has propagated. That's fantastic. Joe will then save that video for us, and then we'll have a look at how we can now leverage the structure inside Plant 3D. Okay, so moving over to Plant 3D, in order to now leverage that structural file, like I've mentioned, we will use standard X-ray functionality. Now, in this particular case, to keep all the files visible and, you know, in line with our processes, what we've done is we've copied the Advanced Steel file into our plant project. So I'm going to go ahead and I'm going to start this video as well, just so you can see how that works. So you'll see how I've copied that file in. Now, when we bring this data into Plant 3D, like I mentioned previously, it is imperative that you have the object enabler installed so that it's visible. So there you'll see how that plant displays that Advanced Steel model that's come from Advanced Steel. It's been copied into the project. Here you'll also notice how the property information and metadata from Advanced Steel is also translated back to Plant 3D as well. Now, once we've verified that the structural model from Advanced Steel is correct, it is loading up correctly, we'll then actually go and swap out the conceptual file that was originally exported. So over here, you'll see the original file that was exported, the structure that was created inside Plant 3D. And then just utilizing that standard X-ray functionality, we would go and detach the one and then go and attach the Advanced Steel file. Now, any changes that are made to this Advanced Steel file by the structural team will obviously be reflected throughout. The only tip over here, or the only thing that's important over here really, is that going forward, the structural team would need to reference or at least utilize the Advanced Steel file that is now residing within the plant project. So that's really it on that workflow. So how one would collaborate with structure from process, or vice versa. As we can see, it is a fairly straightforward process. So that's really it from me on my side. If there are any questions, guys, please, if you can utilize either the chat section or alternatively, you can unmute your mic and you can ask it from there. While you think about something to ask, if you are thinking about something, or to give the guys who are typing a little bit of time, I'm going to launch another poll very quickly. And if you don't mind, once again, just taking a couple seconds to vote on that one for me as well. So you should see that on your screen. And that's really, once again, around collaboration. And would you like to collaborate in the cloud? Okay, guys, thanks for your responses on that poll. Looks like everybody has voted. I'm going to end this polling session. And then just to ask real quick, I see that there are no questions that have been posted inside the chat. So just once again, from our side, I would like to say thank you very much to everybody for taking the time out to attend. As you know, we're trying to keep these sessions short and sweet. If there is anything more you would like to know on how these two applications can integrate with each other, or how to better leverage data from one discipline to another, please don't hesitate to get into contact with us. We are here for that reason, and we are more than willing to assist. So again, thank you very much. Have a fantastic week, and we will chat to you a little bit later. Thanks, guys. Cheers.